For most of computing history, operating systems were simple to understand. You bought a computer, installed an operating system, and used it for years. Windows was something you owned locally on your machine. Linux distributions worked similarly, although they focused more on openness, customization, and community-driven development. The operating system itself was the center of the computing experience. But by 2026, that idea is changing completely. Operating systems are evolving into something much larger than traditional software. Windows is becoming a service while Linux is becoming a platform, and this shift is quietly transforming the future of computing. At first, the phrase Windows is becoming a service sounds like another way of saying Microsoft releases frequent updates. But the reality goes far beyond that. Microsoft no longer treats Windows as a standalone product people purchase every several years. Instead, Windows has become part of a constantly connected ecosystem built around subscriptions, cloud services, AI systems, online identities, and recurring digital experiences. If you look closely at modern Windows, the signs are everywhere. Users are encouraged to sign in with Microsoft accounts during setup. OneDrive integration is deeply built into the desktop. Microsoft 365 appears throughout the interface. Copilot AI relies heavily on cloud processing. Search systems connect directly to online services. Security tools communicate continuously with Microsoft's servers. Even recommendations and productivity features increasingly depend on cloud intelligence. Windows itself is no longer just local software installed on a computer. It is becoming a service layer connected directly to Microsoft's infrastructure. This shift also changes Microsoft's business model. Years ago, Microsoft earned massive profits selling Windows licenses. But modern technology companies increasingly depend on recurring subscriptions and cloud ecosystems rather than one-time purchases. Microsoft now makes huge revenue from Microsoft 365, Azure cloud services, enterprise subscriptions, Xbox Game Pass AI integrations, and online productivity platforms. Windows acts as the gateway keeping users connected to all these services. That is why modern Windows behaves differently compared to older versions. Features no longer wait years for completely new operating system releases. Updates arrive continuously. AI systems evolve online. Security tools receive cloud-powered intelligence constantly. Windows behaves less like finished software and more like a continuously managed digital environment. Artificial intelligence accelerated this transformation dramatically. In 2026, AI is no longer treated as a separate application category. Microsoft integrates AI directly into the operating system through Copilot and cloud-based productivity tools. Users can summarize documents, automate workflows, search naturally, and interact with their systems conversationally. But advanced AI systems require enormous computing power. Most modern AI relies heavily on cloud servers because local computers alone cannot efficiently handle the workload. This naturally pushes Windows further toward becoming a service-oriented operating system, connected to Microsoft's cloud infrastructure. Enterprise computing shows this shift even more clearly. Large organizations no longer manage Windows devices as isolated office computers. Businesses use cloud-based systems like Microsoft Intune, Azure Active Directory, and centralized endpoint management platforms to control thousands of devices remotely. Security policies, software deployment, identity verification, analytics, and compliance management all operate through cloud ecosystems. In many companies, the operating system itself matters less than the services surrounding it. Windows becomes one component inside a larger managed infrastructure controlled through Microsoft's cloud platforms. Microsoft's investment in Windows 365 and cloud PCs reveals where this future may eventually lead. Instead of your desktop existing mainly on local hardware, your workspace becomes a streamed cloud service accessible from almost anywhere. Your files, settings, applications, and workflows follow your account rather than your device. This is the logical conclusion of operating systems becoming services. The physical computer becomes less important. Your connection to the ecosystem becomes more important. For many users, this future sounds incredibly convenient. Files synchronize automatically. Cloud backups protect important data. AI tools improve productivity. Businesses gain centralized management. Devices become easier to maintain. But this shift also changes the relationship between users and their computers. Traditional operating systems gave users strong local control. Service-oriented systems gradually reduced that independence in exchange for convenience and integration. Online accounts become increasingly necessary. Features update remotely. Telemetry expands to support analytics and AI systems. The operating system becomes part of a larger corporate-managed ecosystem. At the exact same time Windows evolves towards services, Linux is evolving in a completely different direction. Linux is becoming a platform. And the difference between a service and a platform matters enormously. A service is something users consume under centralized control. A platform is something developers, companies, and communities build upon. Windows increasingly focuses on delivering connected user experiences managed through Microsoft's ecosystem. Linux increasingly provides the foundation underneath modern computing itself. By 2026, Linux powers a massive portion of global technology. It runs web servers, cloud environments, Android smartphones, AI clusters, supercomputers, industrial systems, networking hardware, embedded devices, and gaming handhelds. Most people use Linux-powered systems every day without realizing it. Linux achieved this position because it is extremely flexible. Companies can customize Linux deeply to fit their own needs. Developers can modify kernels, optimize performance, automate deployments, and scale infrastructure without depending on one corporation's permission. Cloud computing accelerated Linux's rise dramatically. Modern cloud infrastructure demands scalability, scripting, automation, virtualization, and containerization. Linux excels in all these areas. Most cloud providers rely heavily on Linux because it adapts perfectly to distributed environments. Containerization changed software development entirely. Technologies like Docker and Kubernetes allow applications to run inside isolated containers rather than depending heavily on one specific operating system setup. Linux became the natural platform for this approach because its architecture works exceptionally well with containers and orchestration systems. Today, developers often think less about specific Linux distributions and more about Linux as a universal deployment platform. Whether running Ubuntu, Fedora, Debian, or custom enterprise systems, Linux provides consistency underneath modern cloud infrastructure. Artificial intelligence strengthened Linux's importance even further. Most machine learning frameworks are optimized primarily for Linux environments. AI research labs overwhelmingly use Linux systems. GPU acceleration workflows operate best on Linux. Supercomputers almost universally run Linux because it offers unmatched scalability and flexibility. Ironically, even Microsoft depends heavily on Linux now. Azure supports massive Linux workloads. Windows subsystem for Linux allows Linux environments to run directly inside Windows. Microsoft contributes to open-source projects because Linux became essential to modern infrastructure. The operating system wars of the early 2000s no longer define the tech industry. Back then, Windows and Linux competed directly for desktop users. In 2026, they increasingly serve different technological roles. Windows focuses on becoming the dominant service ecosystem for users and enterprises. Linux focuses on becoming the universal platform underneath modern digital infrastructure. Gaming demonstrates this transformation perfectly. For decades, Windows dominated gaming almost completely because of DirectX and widespread developer support. Linux gaming remained niche and difficult for average users. But Valve changed everything with the Steam Deck and Proton compatibility technologies. The Steam Deck represented much more than just another gaming handheld. It showed that Linux could deliver polished mainstream gaming experiences. Proton allowed thousands of Windows games to run effectively on Linux systems. Vulkan graphics technologies improved compatibility and performance. Millions of gamers now use Linux-based systems without even thinking about it. This is how platforms become successful. They become invisible beneath the experience itself. Meanwhile, Windows gaming increasingly revolves around service ecosystems like Xbox Game Pass, cloud gaming, online synchronization, and subscription-based features. Again, Windows evolves toward centralized services while Linux evolves toward foundational infrastructure. Privacy and ownership also play major roles in this transformation. Service-oriented systems naturally gather more data because cloud connectivity powers synchronization, personalization, AI functionality, and analytics. Many users appreciate the convenience this provides. Others worry about reduced local control and increasing dependence on centralized corporations. Linux strongly appeals to users and organizations prioritizing transparency, flexibility, and independence. Governments, researchers, developers, And infrastructure companies often choose Linux because it avoids vendor lock-in and allows deeper customization. Neither approach is universally better. Service-oriented systems solve many real problems extremely well. They simplify management, improve accessibility, and enable advanced AI-driven experiences. Platform-oriented systems provide resilience, flexibility, and openness impossible within tightly controlled ecosystems. The future of computing increasingly depends on both models simultaneously. Education already reflects Linux's importance as a platform. Students learning cloud computing, cybersecurity, DevOps, AI development, and software engineering regularly encounter Linux-based workflows immediately. Most cloud certifications assume Linux familiarity. Modern development pipelines rely heavily on Linux infrastructure underneath. Linux knowledge increasingly represents understanding modern infrastructure itself. At the same time, younger generations often think differently about computing compared to older users. Many care more about ecosystems and online services than traditional operating systems. Files synchronize automatically. Applications live in browsers. AI assistants organize workflows. Streaming services replace ownership across entertainment and increasingly across computing itself. This cultural shift strongly favors service-oriented ecosystems like Microsoft's evolving Windows strategy. Users become connected to identities and cloud environments rather than individual devices. But Linux continues spreading quietly underneath nearly everything. Android smartphones use Linux kernels. Internet infrastructure relies heavily on Linux servers. Smart devices, automotive systems, industrial platforms, and embedded technologies increasingly depend on Linux foundations. Linux became powerful precisely because it became invisible infrastructure. Artificial intelligence will likely push both trends even further during the next decade. AI-powered services require enormous cloud ecosystems, which benefits service-oriented operating systems like Windows. But AI infrastructure, GPU clusters, research systems, and decentralized AI environments overwhelmingly rely on Linux underneath. In many ways, both Windows and Linux already achieved victory, but in different areas. Windows dominates mainstream service ecosystems for productivity, enterprise management, and consumer experiences. Linux dominates infrastructure, cloud systems, AI computing, and embedded technologies. The future is not about one operating system replacing another. It is about two completely different visions of computing evolving side by side. Windows increasingly represents the future of connected digital services powered by AI, subscriptions, cloud integration, and centralized ecosystems. Linux increasingly represents the future of open infrastructure powering modern technology beneath the surface. And perhaps the most important realization is this: operating systems themselves are no longer the final destination. They are becoming either intelligent service layers above everything or foundational platforms underneath everything. That is the real future of operating systems in 2026.